And hello everybody! Welcome to Super Make Something Live, the first official ever build-along where we will be building a DIY Stream Deck. Thank you everybody so much for tuning in. I hope today is going to be a great live stream. Before we get started, I'm going to quickly shuffle over here just to double check OBS so that I can keep an eye on the audio levels. And those all look good. But yes, so thank you very much for tuning in. Welcome to the stream. Hopefully you guys have had a happy holiday season so far and have had some time to relax, spend some time with family, and yeah, are ready to build. So in case you don't know, I am Alex. I recently built a project video for a DIY Stream Deck. And I thought that today would be a good opportunity after the holidays, between Christmas and New Year's for me, to basically sit down, have a live build of the device, and let you guys ask any questions in case you guys have any as we build this Stream Deck, and just kind of do a deep dive into the build from start to finish. So throughout this live stream, I'll of course be keeping an eye on the chat. If you guys have any questions, do please feel free to reach out. Let me know. In case something does go wrong with the stream, hang tight, just in case maybe connection gets interrupted or something like this. I will be right back and restart the stream. But in the meantime, I guess if there is no further questions, please, get set and get ready to build. Alrighty. Quickly, before just starting out here, I'd like to give a big thank you to the sponsor of today's video, who is PCBWay. PCBWay, of course, is a PCB manufacturer that I use for a lot of my projects, and they also graciously supplied these circuit boards for this live stream to me today. We're going to go into exactly how you can order your own circuit boards for this project a little bit later into the build. But essentially everything here is designed around these circuit boards in a way that it's as easy to solder as possible, so that hopefully anybody who wants to build one of these Stream Decks for themselves will be able to do that. So with that being said, if you are new here, you might have a question of what exactly is a Stream Deck? And a Stream Deck is essentially a device that acts like a macro keyboard. So a lot of times you may need to have certain keyboard shortcuts tied to kind of one button. For example, if you do something a lot, if you're example in Photoshop and you do a lot of copying and pasting, instead of having to hit Control V and Control C, instead what you might do is you might assign that to a single button on a keyboard, and then that basically pressing that single button on the keyboard then acts like pressing Control C and Control V together. And in general, that's pretty manageable when you're only working in a single application like Photoshop or something like that. But it can get a bit difficult to manage if you have a lot of applications that you're trying to assign macros or keyboard shortcuts into. And it also can get a bit messy when you have a lot of macro shortcuts assigned to different keys. So in that case, for standard macro keyboard, the responsibility would be on you who assigned all those macros to the keyboard to basically remember what each key does on your keyboard. A Stream Deck solves this problem a little bit, especially in situations like this maybe, where you're going live and you want to control stream software, where you necessarily don't always want to pay attention or exactly to what keys you have to press and remember a bunch of key combinations. So the main thing behind the Stream Deck is that in addition to being a macro keyboard, it has an LCD screen behind each of the buttons. And those LCD screen buttons can update dynamically based on what shortcut is assigned to the key. And what that then does is it basically gives you visual feedback to let you know exactly what every key does. So having that little stream underneath each key can definitely be handy for being able to switch back and forth quickly, especially in something like during a live stream where, for example, you have scene transitions and you need to have graphics fly in and out and you want to have a microphone mute button. So it's basically just a nice way to kind of make sure that you always press the right button. And you always press exactly, and you always do exactly what you intend to do. So let's see. So like I said, basically the main thing that everything is built around is the circuit boards here from PCBWay. And what happens with these boards is the idea is that basically we have two circuit boards. One set of circuit boards is responsible for connecting the Arduinos that we use for controlling the Stream Deck keyboard to one PCB, and then we also attach the screen to that. And then afterwards, there's a secondary button PCB that basically sits on top of that LCD screen. And that then communicates with the Arduino sitting below, and then updates the keyboard presses accordingly. So let me see, really quick, switching back and forth. And as you saw right there, that is exactly what a Stream Deck is potentially good for, being able to quickly turn graphics on and off. So the main components of the Stream Deck that are in here are as follows. Of course, we have the LCD screen that we're going to be using to display everything. So in this case, it's a 3.5-inch colored touchscreen that's compatible with the Arduino. So that means it has basically some software libraries that are written for Arduino, so you can basically easily use it with that kind of microcontroller. The next thing that we use is an SD card reader. So this also connects to one of the Arduinos. And basically, this SD card reader stores all of the graphics that you might want to assign to each of the buttons because neither the Arduino nor the LCD screen have enough memory in order to actually store any graphics. And this also makes it easy to update graphics onto the Stream Deck, because instead of having to reprogram the Arduino every time when you want to update a graphic, you can simply replace the files on the SD card within this SD card reader and reassign icons as needed that you make in Photoshop or some other graphics editing program. So that's a nice handy thing. Of course, we then have the two PCBs. So in the bottom left, you see what we call the motherboard PCB, and this motherboard PCB has connections for mounting an Arduino Nano, and the Arduino Nano is responsible for driving the screen and accessing the SD card reader, as well as an Arduino Pro Micro. And the Pro Micro is a key component of this build because unlike some other Arduinos that are this size, this Arduino has the Atmega32U4 chip. And what the Atmega32U4 chip allows you to do is to basically pretend that the Arduino that you're connecting to is a USB keyboard. So for example, the Arduino can then be programmed at the push of a button to send a keystroke as if it were a USB keyboard to the PC. And then what that allows you to do is say, okay, now I press a button, for example, the A key or the B key, or crazy combinations like Shift Control X, for example, if that's a macro that you want to assign. And again, the nice thing about this is that it's very programmable, so you can basically assign any number of keystrokes in series to the Arduino at the push of a button. So even, for example, if you wanted to have a quick chat message and you wanted to send an entire sentence with the push of a button, you could basically make the Arduino send out all these keys, afterwards then hitting enter, and then you'd be basically good to go, and you have this well-assigned keyboard button. The other thing, of course, that I did not mention yet is that in addition to the buttons, something that other Stream Decks currently do not have is the ability to have any kind of rotational motion. So for example, if you're editing videos and you want to scroll left or you want to scroll right really quick, or you want to update or you want to change what the volume is, for example, on a live stream, so volume up, volume down. Usually for something like a car or your speakers, you have a volume dial that you can turn up and down. But currently most Stream Decks that exist don't have it, this feature. They only have buttons that you can press. And of course for me, if you've been following the channel for a while, I of course edit a lot of video for all of the projects that I make. And two of the features that would really make my life easier for editing video very quickly is to be able to scroll through video left and right in order to make cuts more quickly, and then also to adjust volume levels while editing. And because of that, I've added Also, the capability to integrate this rotary encoder into the Stream Deck, which you see on the button PCB there on the left-hand side. And again, these just rotate left and right. Basically, I will assign these to arrow keys within the Arduino code. But one advantage is that they also click. So click, click, click. And that is nice because that essentially gives you an extra set of 2 buttons for your Stream Deck where even though they might not have an LCD screen under them, again, for editing, it's very handy, for example, to be able to rotate left and right, and then to be able to click that button down and then be able to splice a video, for example, or insert a transition, or do anything like that. Alrighty, so with that being said, I think it's now time to actually get started with the build. And I hope you guys all have your soldering irons ready, because here we go. So here is the electronics workbench that we're going to be using today. Here are basically all of the components that will be included with the Stream Deck, and with the addition of a bottle of water, just in case we need a drink while we're soldering. And I think that the probably best place to start to solder would be to begin by populating this board right here. So this board is the interface board with the Arduinos, as well as the ribbon cable that connects the two. So what we're going to do is we're going to move everything out of the way here, make some space, and we're going to switch over to desktop view to give you guys a little bit of a better view, where I have also connected a USB microscope that we can, to give you guys kind of a close-up view of while we're soldering. I'm going to find the brightness adjustment here. There we go, perfect. All right, I'm gonna move this guy over here. And then I will also give you a view of the bench. So again, in case you guys have any questions, please do let me know in the chat. We have a chat box here. We see that the chat is active and live. So yeah, please feel free to reach out and let me know if you guys have any questions. Alrighty, first things first, soldering iron on. And the other thing that we're going to turn on here is a fan. This fan has a filter built in, and that basically is just to kind of draw the solder fumes away a little bit, just so that you're not breathing these in while you're soldering, because that's not kind of the greatest thing to do. And then the first thing we'll take a look at here is the Arduino Nano, which is right here. So once the iron is hot, what we're going to do is we're going to put this guy into the circuit board like this. One of the nice things about these Arduinos, depending on where you buy them from, is that a lot of times they'll come with the headers pre-soldered. So that's nice, just because that does take that does save you some time just with soldering, just because obviously an Arduino has a lot of pins. So in case you have seen the previous Stream Deck video and you guys were just wondering a little bit kind of the motivation behind this project. So at the beginning, of course, we're all currently within the COVID pandemic, and that caused a lot of people to get interested in live streaming for both kind of on YouTube or Twitch like we're doing now, because a lot of people were stuck at home, so they wanted to try something new. But also a lot of people, for example, use them in business settings, for example, for Zoom calls and things like that. And in general, that was pretty nice. But what that meant is for people that were interested in purchasing a Stream Deck from a company, for example, like Elgato, was that they were all sold out. And of course, when things are sold out, there will inevitably be scalpers, just like we saw with the PlayStation 5. And what we saw was a huge markup. And I thought, okay, scalpers really aren't fun. Obviously, that's something that nobody likes. So the best way I thought to kind of help out the community would be to design my own Stream Deck. And the thinking there was that, if I'm going to be designing my own Stream Deck for everybody to use, I can, one, add some functionality to the Stream Deck, which of course would be great for, again, adding things like encoders, things like that. And real quick, I'm just going to see if I can maybe boost the brightness here a little bit, just to make it a little bit easier to see. 1 second. Okay. And adding some functionality, but then also with the hope that, since I wanted everybody to be able to build the Stream Deck, to make it as easy to assemble and solder as possible. So from a design philosophy standpoint, that meant a couple of things. So first, it meant that I wanted to try to use as many commercial components as possible that people are familiar with, and kind of arguably the easiest microcontroller right now to use and to program with is the Arduino. So I decided to base my entire project around Arduino. Let me switch back to the secondary view really quick. To design everything around Arduino. And then with that in mind, I also wanted to choose Arduinos that were small to try to approximate the size of a Stream Deck that currently exists that you might be able to keep on your desk. But then I also needed to find basically compatible hardware where software libraries already existed to make sure that the amount of code or amount of code editing that somebody would need to do would be minimal in order to build one of these Stream Decks for themselves. So I went online and found an LCD monitor that was perfect for the application, but there was a little problem with the LCD monitor that I found, and that is that it was primarily designed for the Arduino Uno, which has a lot of pins. And the Arduino Nano is basically an Arduino Uno but smaller. But the issue was that it basically had just a few too many pins in order to interface with either the Atmega32U4 Arduino Pro Micro, again, which emulates a USB keyboard, or the Nano directly. So I thought, okay, I definitely don't want to use a different microcontroller just because, for hobbyists that are maybe just starting out with this project, those ecosystems, software ecosystems aren't as well developed. So the easiest solution for me was to basically instead of just using one Arduino, is to use two Arduinos. And that's why we have two Arduinos in this Stream Deck. So both an Arduino Pro Micro and Arduino Nano. And therefore the function of both Arduinos is basically split up into two parts. So one where the Pro Micro simply acts as a USB keyboard, and then the Nano is responsible for everything else in terms of reading files from the LCD screen and updating the graphics display and loading everything properly. So, all right, so this Arduino is almost done. All right, let's see how those look. Make sure that there's no bridged pins. One thing I've noticed here with this lighting, it is a little bit difficult to see. I know it might not be showing up on camera, but currently the light is off in my room. So let me go turn that on just so that it's a little bit easier to see. Boop. All right, everything just got a bit brighter, which is cool. And we'll just keep this on while we're soldering. Okay, let's really quickly also take a look at the chat. Let's see. Yep, way too close to see anything. All right, thank you. Yep. So gonna move back a little bit. Tobias Werner asks, "Is it possible to watch the clip afterwards on YouTube?" Yes, it will be able to watch it on YouTube. We'll be uploading this later as a full episode. It says, I think, is it possible to use a touchscreen LCD versus a switch PCB? So yes, so that was another thing that we were getting a lot of questions on in the video itself for the project. The question was, is it possible to use a touchscreen? And at the beginning, while designing the project, that was kind of a design choice that I made to not use a touchscreen, just based on the overall price that I wanted the project to have. So I wanted to make sure that it wouldn't be too expensive for people interested in building a Stream Deck for themselves to build, So basically, the only kind of touch screens that were available were resistive touch screens that are, available for kind of some hobby applications. And those are pretty good for what they do. But my concern there was that basically it wouldn't be the lifetime of the resistive touchscreen might not be kind of high enough, and the screen could get damaged. For example, if you're on stream and you're pushing buttons very hard. So what I wanted to do is I basically wanted to make sure that the touchscreen kind of gets, or that the LCD screen would get pushed as little as possible, just in an attempt to make sure that in case any of the components are kind of mass-produced or a little bit of lower quality, again with the intention of keeping the price down, the project would hopefully have a longer life. So because of that, I opted to make a button PCB, but certainly it would be possible to redesign this project using a touch screen. So, alrighty. So one thing here is that the Pro Micro that we had does not come with any headers. So that is one thing that we're going to have to solder on here as well. And let's see, I'm just going to get them started here. Make sure that these are on straight. Oh. Actually, let me do this. This would be easier. What I'm going to do is I'm going to see if I can have a little trick here. So one trick for soldering header pins that I found is instead of trying to solder everything onto the kind of balancing everything, if you have some perf board, what you can do is you can put, or some kind of prototyping board, what you can do is you can insert the headers really gently into here, into the board. And then what that'll do is it'll just keep everything nice and straight while you're soldering, at least for male header pins, just like this. So I'm going to put that in here. Okay. Perfect. All right, I see right now in the chat there is some discussion going on about using a Raspberry Pi and Python. Certainly that's one of the things that you could do, and you'd kind of be trading off maybe complexity a little bit of the software that you may need to write, and the kind of the power of the Stream Deck with some niceties. So one thing we'll notice here kind of towards the end of the build is that certainly one of the limitations of the Arduino is that the processor in it kind of has a tough time of updating the pixels of the LCD screen during every cycle, just because of the clock speed of the processor on board. What that means is that basically the icons refresh a little bit slowly compared to, if you would use a more powerful microcontroller, which again might not be as easy to program, or a Raspberry Pi. And a Raspberry Pi obviously gives you the advantage of having an HDMI out, so it can drive a full HD display very quickly. But the problem I personally think with the Raspberry Pi is that you would basically need to have an SD card that runs a full Linux operating system on board, and that can be okay, but certainly having to install an operating system for what's essentially a macro keyboard, I thought might be a little bit too complex. But again, that's up to, I guess that's up to the individual. So this project could certainly be remixed using that, but I decided to use an Arduino. Okay, I see here, do you have a fan for the soldering fumes, or is this a non-issue? So yes, I do have a fan for the soldering fumes. Actually, it's covered up right now by the screen, but it's right here. Definitely, you do not want to be breathing solder fumes if you can avoid it. So definitely, that is something that I would recommend everybody use if they are going to be doing a lot of soldering, certainly with a project like this. Just because, yeah, you know, if you're using lead solder or any other kind of solder, it's certainly probably not the best to breathe. So if you're going to be doing any kind of electronics work, I would definitely recommend those to kind of both professional people that, you know, do a lot of soldering, as well as hobbyists that are just getting into soldering, just because those fumes can be quite harmful. So this guy's almost done. One thing I noticed here while soldering this guy is that the male header pin for the raw voltage isn't coming through. I'm wondering if maybe I lost a pin. Let me get this guy off here real quick. Take a look. Let's see what's happening to that pin. Oh yeah, check that out. So it looks like we sprung a pin here. Oh, can I get this camera to focus? Yeah, I'm gonna move out of the way, try to get it to focus a little bit. Nope. All right, let me switch over to the secondary camera then. Basically, one of the pins right there, as you can see, got super long. So we're gonna adjust that real quickly. And the way I'm gonna do that is I'm basically going to heat up the solder or the pin, and then push it through, just like that. Boop. Okay, very cool. And we are back in business. Alrighty. All right, with those header pins populated, let us now go and solder this guy onto the board, just like so. And what I might do too also is, one of the downsides, I guess, of buying this particular microcontroller for the Arduino Nano is that in addition to having these connection headers already populated, it also had the in-circuit programmer header populated right here. For the Stream Deck design that we're working with, that unfortunately is a little bit tall. So what I'm going to do is also just snip off these in-circuit programmer leads because we don't need them. The way I'm doing this is with a set of snips right here. One thing to be careful with is that when you snip off big pieces of metal like this, they do have a tendency to go flying. So either wear eye protection or just put your hand over it. So as these pins pop off, you can just cleanly snip them off, and boom, we are ready to roll. So I see. So Michael Cutler is saying, thanks for the stream, Super Make Something. It's 11:30 here in Singapore, so I'll watch the recording in the morning. Best of luck. Thank you very much, Michael. Thank you for tuning in. And yeah, I hope you enjoy the replay of the episode. All right, on to soldering the next Arduino. Oh yeah, it's definitely a lot easier to solder when there's light. So apologies that the LCD kind of microscope here, where I wanted to show you guys an up close of the soldering, isn't working. The zoom on it seems to be a little bit aggressive, and there's no good way for me to adjust it at the moment. I guess it's handy definitely when you're trying to do little SMD work, but certainly having to watch that full stream on live stream can be a bit close. So for the next live stream of this type that we'll host, I'll definitely look into getting a different one. But for now, I think we'll just kind of keep the secondary camera view with the desktop. So definitely also the solder joints are a lot prettier when you're not soldering in the dark. Who would have thought? So, all right, almost done. I will say that if you end up building this project and you're new to electronics, definitely by the time you solder all of the pins required for this project, you'll definitely have gotten a lot of practice in the soldering department. Certainly a good skill to have, for electronics work, so that's good. But one of the things, again, that I did try to avoid was to, at the cost of being able to make the Stream Deck as small as possible, I opted to only use through-hole components, so then that would make things kind of as easy to solder as possible. So, okay, so both of the Arduinos are on. It is now time to solder the female header pins. One quick note, though, before we solder that. So what you may notice here on the board is that there is a couple of extra connections that I did not mention during the project build video. So one here is we have a bunch of resistor terminals and then a bunch of through holes here, which you can use to add LED lighting to the Stream Deck, which is pretty cool. But then eagle-eyed viewers may have also noticed that there is an extra set of holes here for an additional push button right there. And what I had intended for that button to be was to basically, what I did is I connected that to an extra I/O on the microcontroller, and I think Streamlabs just crashed. Oh no. So we have a little bit of a technical problem right here. Streamlabs just crashed, and that's kind of a, that's bad. So that's good. You guys can still hear and see me. The only issue with this now is that I can't change Streamlabs streams anymore. So what I'm gonna do is I'm basically going to restart Streamlabs. Then that can then restart the stream, and then I'll regain things like functionality like being able to show you guys the desktop. All right, guys, hello, I think we are back. I apologize for that snafu during live streaming. Streamlabs crashed, and unfortunately, as far as I know, there is no way to actually restart the stream once you disconnect, because YouTube assumes that the stream is complete. So my sincere apologies. I do see that we're getting some people back, and that the stream seems to be going. The stream seems to be back. We are getting some chat messages in here, which is fantastic. Hi, Hybrid. Okay, great. So it looks like people are finding the new stream link. My sincere apologies about that. I don't quite know why that crashed, but let's keep going. I'm going to pull the stream back up on my phone here, just like that. Okay, and we are back. Okay. Whew. Alrighty. So we were in the middle. Of soldering. Okay. Just got a question. Are you 3D printing? So I have already 3D printed all the parts, just because that would take a little bit of time to get everything together. So I just decided to print all the parts ahead of time, but I'll give a couple more details of that in a minute. So. Alrighty, so we are back again. Sorry for that technical hiccup, and thank you for bearing with me here. Okay, perfect. Let us continue. So, the next thing that we need to do, we need to cut the female header pins. So, what we're going to do is basically take these sets of female headers and solder everything in. So what I like to do for that is I like to take essentially a lighter and an X-Acto knife, and I like to heat up the lighter with the X-Acto knife like or like to heat up the X-Acto knife with a lighter like this. And then I like to cut them right down the middle and just pre-score them a bit so that they're easy to snap off. So here we go. The downside to this is, unfortunately, you always lose at least one pin while doing this. I really wish they made kind of female breakaway headers, because they do also make male breakaway headers, but what can you do? All right, I'm gonna cut this off here like this. Okay, snap it off, and then start to solder these female header pins. So I just see a notification that says, don't forget that after 3 live streams or uploads, YouTube doesn't send out notifications anymore if you do that more than once a day. Thank you. That is a good thing to know, because actually I need to make sure that that is something to be aware of. I hope, like I said, we're not going to have another crash. That's unfortunate that happened, but hey, we'll go on. And I guess what we can do after the fact is we can basically edit the 2 videos together and then continue on as if it were something that never happened. So that's something that I will do at the conclusion of this live stream. Okay. Right? That's just such a such a 2020 way to end things with a live stream crashing. But that's okay. At the end of the day, it's supposed to be fun, and hopefully people will be able to find the live stream after the fact. All right. I'm going to cut these female header pins here. 1, 2, 3, 4, 5, 6. Going to pull out one of these pins here. And heat it up. Just like so. Hybrid is asking, what am I doing right now? So right now what we're doing is we are populating this board with female header pins. So right here we have a set of female headers that are going to be used to connect this LCD screen to the board. And so that is what we're doing right now. So basically I am cutting all of the female headers here. And as soon as we cut all of the female headers, what we're going to do then is we're going to solder them in. So 1, 2, 3. Yeah, thank you for your support there, Akits. He said, if that's all that happens and you end up with a nice Stream Deck, I'll say job done in 2020, and here we come 2021. Yes, thank you so much. That's awesome. I really appreciate it. And I agree. Overall, you know, things again could definitely be worse for sure. Cutting this. Almost done here. This will be the final set of female headers that we will have to make for this project. Sometimes though, I guess, again, these, unlike male headers, these unfortunately are not breakaway headers. So that's a bit of a bummer. So what you have to do is you basically have to use a set of pliers or other tool to snap them in half. If anybody has I guess a better way or a suggestion of how to kind of separate these in a better way, I would love to have a tip. just because that's personally something that I've always struggled with, is to make sure that the female headers break away cleanly. So, clip. All right. Nope. Okay. And just pre-scoring these a little bit before we actually snap them. Hello, Philippe. Thank you so much for rejoining us on this stream. Alrighty. Have to trim this off a little bit as well. Just like that. Oh, so Diego says that he thinks there is no good way to separate the headers. Yeah, I agree. Hello everyone who is rejoining the live stream. Again, we unfortunately previously had experienced a bit of a hiccup and Streamlabs had crashed. So thank you again very much for rejoining us here. I really appreciate you guys tuning back in. And hopefully we can avoid another crash in the future. Alrighty. Yep. And they're saying, my front camera, Philippe is saying, is not in a good place. Can I move it up? Yes, sir. I certainly will do that. Right now. Let's zoom in a little bit. Okay. There we go. Felipe, please let me know if that is better. A little bit easier to see. Perfect. Okay. So now we will begin and solder all of the female header pins. Again, a big thank you to PCBWay for sponsoring this live stream. After we solder these header pins, what I will do is I will switch over to the desktop view really quickly. And then I will show you guys how to order these circuit boards for yourself. Okay, Felipe says that angle is much better for soldering, so thank you very much for that feedback. That's there. I'm asking Carrie Illuminati, can you see me? Yes, we can see you in the stream. Thank you very much for stopping by in the chat and hanging out. Almost done here, soldering all the header pins. just like this. Perfect. Okay, and we have a set of soldered female headers. Perfect. All right, this board is almost complete. And all right, right now what we're going to do is let me quickly switch over to desktop view and turn off these secondary solder pins. Let's see. All righty. And real quick, so like I had said previously, all of these projects are, so the entire Stream Deck project was basically meant for me to create a Stream Deck that I needed and wanted based on the functionality that I needed and wanted. But I also released all of the files for you to build your own on GitHub as an open source project. So the idea is that you hopefully will be able to go in and remix the Stream Deck to best suit your needs. And all of the files can be found at github.com/supermakesomething in the GitHub repository for the DIY Stream Deck. So here you'll find the Arduino code and all the Arduino libraries, as well as the 3D printable CAD models and the Gerber files that you can use to get your boards fabricated, as well as an initial set of starter images and icons. But in case you are simply interested in building the exact same Stream Deck that we are building here, underneath the intro text of this GitHub repository in the README, you will find a link to the bill of materials, and the first of that is PCBs. So through PCBWay, who is sponsoring this video, they have a really cool thing called a community portal where people can basically upload their designs and easily share them. And the nice thing with that is that it basically allows you to add all these boards to your project with a single click. So after clicking on that link, you're basically taken to the project page for the DIY Stream Deck. There are separate pages for the button PCB as well as the motherboard PCB, so be sure that you are able to add both. But simply all you do then is you click Add to Cart, and it will immediately take you to the ordering website where it then populates all of the board parameters, and you can customize several options for the PCBs. So for example, I opted to have a white silk screen, so that's the white lettering, as well as a black solder mask. But then I opted to, instead of having the standard silver finish, I opted to go with an immersion gold finish called an Enig finish. And this does two things. So one, with the kind of logo and everything being exposed, it just makes kind of the logo look really cool and the circuit board look really cool, kind of give it a techie feel. But the main motivation is that if you were to order, say, more of these, say you want to build 2 or 3 Stream Decks, the nice thing that you are able to do here is that with this Enig finish, you're not going to have any of the kind of solder points oxidize or anything like that over time. So in case you don't build all of the circuit boards right away, you can store them and they will last a little bit longer. Plus, Enig finishes are a little bit nicer to solder and easier to solder. Then just going back here, so like I said, this was for the button PCB. What you can do is you can also scroll down and you will find a link to the keyboard PCB in the project description. Again, this will give you the second set of PCBs that you need to order this project. And again, you can basically here just click Add to Cart, and it will once again just populate all of your different board options, and then you can then just simply save these to cart. Overall, again, I've used PCBWay now for a couple different projects. Their shipping is always incredibly fast, which I really appreciate. They have a lot of solder mask options, which is also insanely awesome. But most importantly, of course, is their board quality, and their board quality is always perfect. Their prices are also great, so I would definitely recommend them to anyone looking to build one of these Stream Decks, not only, again, because it's very easy to order from them, but certainly my experience with PCBWay has always been absolutely fantastic. and I've always been very happy with the quality of the boards that I've received from them. So again, a big thank you to PCBWay for sponsoring this video. In case you're interested in building a exact copy of the Stream Deck here, that we see here, definitely consider checking them out. And you can find links to all of these things by following the links in the video description below. Alrighty, so while we're doing that, so all of the female headers are now soldered on. And there's 2 more things that we need to do to this board before it is 100% usable. So the first thing is we have to solder a ribbon cable for the, we have to solder a ribbon cable connector here for the SD card. And we also have to solder a ribbon cable connector here for the keyboard buttons. So that will then allow you to basically connect the two printed circuit boards together. So to do that, step 1 is I have got a bunch of ribbon cable here. And what we're going to do is we're going to basically cut a piece of this wire to length, making sure that it's long enough to basically reach through the entire Stream Deck, where we're going to be connecting it to the other PCB. We're going to snip this off here. And then we will begin the soldering process. So what we can do is we will begin stripping all of these wires. So again, thank you so much for joining me today on this beautiful Sunday. I hope that the weather is cooperating wherever you guys are. Here where I am, there is a lot of snow, so you know, that makes it fun to go play outside and build a snowman if that's something that you're into. Alternatively, it's also a good excuse to stay inside because it is quite cold outside, and do things like building a Stream Deck. So just going to strip these wires here, just like this. Andre is asking in the chat, will you remove the onboard LEDs from the Arduino? Won't they shine through otherwise? Right, so as Andre points out, the Arduino does have LEDs in the on board as kind of like status indicators. I will not be removing them just because I guess for 2 reasons. So one, the screen will basically cover anything, and like the light emitted by the Arduino's LEDs will not interfere with the graphics being displayed on screen. But also, again, because this is kind of like a techie / cyberpunk theme that we're going for here with this Stream Deck, having some extra LEDs shine through just kind of looks pretty cool. As a matter of fact, actually, for those of you who are just joining the stream, there are unpopulated holes for additional resistors and LEDs on the interface PCB. And what that basically would allow you to do would be to kind of add other LEDs so you can customize the glow basically of your Stream Deck. So that way, you know, you can kind of customize it a little bit more to your liking, and make sure that the Stream Deck color and illumination that you choose ends up matching with your room. All right, so we have just stripped all of these wires here, and we will strip the other side as well. Just like so. Snip, 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 snip. Snip. Okay. Perfect. And now what we're going to do is we're going to basically take this ribbon cable and feed it through the top here, just like so. Of these holes. Perfect. All right, and just add a bit of solder. Like so. Boop. Okay. One note here. So this ribbon cable will basically flex along the length of the Stream Deck, and there's several different types of wires that you can buy. Either solid core or stranded core, where you have individual strands of wire running through each of these colored leads here. My recommendation would definitely be to buy stranded wire, just because, again, these will flex through the PCB a little bit, or these will run through the Stream Deck a little bit, and just having that extra flexibility just makes everything a little bit more robust. Soldering that on here. Andre is asking, what is the board with many buttons on your laptop? So yes, so again, for those tuning in, for this Stream Deck, we basically have two different buttons. We have one interface PCB, or a motherboard PCB, which we are using to basically connect all of our Arduinos and such together. So that's the board that we're working on right now. There's also a second PCB, which is the button PCB, and that sits on top of that circuit board and on top of an LCD screen, and that basically is responsible for handling all of the graphics. Hi, Dustin. Thank you so much for tuning in to this live stream. Welcome to the show. Okay, so that is soldered. Okay. Continuing to solder here. About halfway there. Okay. Almost there, need a couple more. One thing I think, one design decision I made for this Stream Deck is that because I wanted to make it as comfortable to use and keep it as low profile as possible, I opted to not use any male and female header interconnections were possible, and basically solder things like this ribbon cable directly to the board. Overall, it does a lot to reduce the height of the Stream Deck, but of course that comes at a cost, and that cost being that you have to basically put these individual wire leads through each of the holes, and then solder those in there, which makes kind of the assembly and soldering process definitely a little bit more involved. So like I said, I have released all of the files for free on GitHub, and basically my hope with this design is that people will basically use these files as a starting point that I've released and basically make their own remixes of the Stream Deck. And maybe someone who is, part of or more familiar with the electronics industry and maybe does it professionally, maybe they can put like a really cool connector in here, which is both easy to solder and has a smaller footprint in terms of making the overall Stream Deck a little bit shorter. If that is something that you would be interested in, definitely be sure to head over to GitHub and take a look at the files. We have all of the files for the Stream Deck available there for free for you to remix. And I'd definitely be excited to see, what the community comes up with for future Stream Deck builds. All right. All right, so here we need 4 more ribbon cables now. So I'm going to just separate kind of 4 from this strand here. Oop. Perfect. And I should mention also that the silk screen on each of the PCBs for connections and things like that is labeled so that it's hopefully very easy to know which connections to connect what to. So for example, ground is ground on both PCBs, key 1 is key 1 on both PCBs, and basically hopefully that'll mean that you'll just be able to quickly and easily connect everything together. Just separating the final leads here. And basically, once we finish the soldering, the rest of the assembly is actually pretty straightforward, and we'll be in the home stretch. So certainly the soldering process is the most involved for sure. Or I should say is the most involved part of this project for sure. Oh, and I see in the comments here, Dustin Watts, who is in the chat, along with Johnny Bergdahl, he's saying that Dustin Watts is making his own Stream Deck variant using a screen with a touch screen instead of a button. So that's really cool. I'm very, very excited to see that. If and when you finish that design, please do get in touch. I would be happy to share that design with everyone who's looking to make their own Stream Deck, obviously, because the more Stream Decks are out there, I think the better, and it's really cool to see what people customize and what they come up with. One thing that I will also say is that since publishing the original project video on the Stream Deck, YouTube viewer DSK001 also made his own Stream Deck, and he basically remixed the case to give it a bit more of an industrial look. So that's also really cool. So now I guess at the time, not counting Dustin's design, there are currently three Stream Deck variants. So you kind of have the organic looking one with kind of the Voronoi sketch generated holes throughout the project or throughout the case that was shown in the original project video. Next was the Cyberpunk Stream Deck one, which we're obviously assembling here. And then the industrial version from DSK001. Okay. So yeah, question in the chat. So this assembly with wires is definitely seems like it would be a lot of work. Is there another way? So from what I guess for this design, so I think there is certainly another way to assemble this. But of course, that comes with two trade-offs. So commonly what's done in industry is you have what's known as Molex connectors. These are surface mount solderable connectors, which are very low profile. But I guess in terms of this Stream Deck build, they have kind of two downfalls. So one is that they are usually SMD solderable. So with SMDs, so that's surface mounts, so they're a bit harder to solder, but certainly that's what's used kind of in a lot of the kind of automated assembling processes. The connection is also usually pretty good. The other downside is that they tend to be a little bit expensive because they are a kind of a commercial connector and a somewhat, I believe, proprietary connector. So that would also increase the Stream Deck price a little bit. So, you know, certainly I think different connectors exist. For this variation, I decided to go with wires, again, trying to focus mainly on having a through-hole solderable connection, as well as to try to keep the price down. So if you look at the bill of materials, one of the design goals for this Stream Deck was that with all this scalping going on, for this design, I wanted to make sure that the price of the Stream Deck that we're building here would be comparable to the original non-scalp price version of the Stream Deck that's currently made by Elgato. And you know, obviously, if you're buying one-off parts, that can be a bit difficult to achieve because obviously with a product, you know, you get quantity discounts if you're a big company that buys components. So some of the trade-offs that I made in the design were definitely kind of on the price, I guess with the price in mind. So that's why I'm using these wires. That being said, I definitely think that there are many different options for assembling this Stream Deck. I would very much be interested in seeing kind of what other people come up with. I'm certainly, you know, not against using SMD components in the Stream Deck. It's just that kind of made things a bit kind of more difficult to solder, and I wanted to try to keep everything through-hole solderable. Okay, next step. So we are now at the part where the ribbon cable has been soldered in for the main PCB. So the final thing to do is to connect the SD card reader that we will be storing all of our icons on. In order to save some time, the ones that I bought already came pre-soldered with this male header here. And again, for space reasons, to try to make everything smaller, I need ones without the male header. So what I have done off screen in preparation for this is basically desoldered that male header and also attached wire leads to the other side. So we'll be soldering those in now. Again, the important thing to note here is that these connections have to be connected in a certain way. So in this case, blue is ground, green in my case for the wire is VCC, etc. And I made sure that the buttonholes on the interface PCB that we have here match the order of the pins that are here. So once you get one of the pins right, in this case, again, blue is ground, you basically just have to solder all the way across, and then you should be good to go. So we're going to insert the ground wire first here. And again, I see that we currently have a bunch of people watching. Hopefully a lot of you were able to refine the stream after we had our little OBS crash earlier in the day. So again, thank you very much for sticking by it and coming back and watching us finishing assembling this Stream Deck. All right, so wire 1 is in. 2 is going in here. Just like so. Wire through. All right, almost there. After which point, it's going to be time to move on to the button PCB. I do have to say though, I just love the way that the black solder mask with the gold finish looks. It just looks so cool. Like that color combo with the white text is a personal favorite of mine. All right. Last wire for this guy. Make sure that there is no loose leads. Yeah. Okay, we are soldered up with the SD card connector. Just going to trim a little wire lead here that I see hanging out. Again, this is one of the things you have to be careful of if you're not using male header pins, is that if you're just connecting circuit boards kind of together using wires soldered directly into the board, you want to make sure that no strands to kind of go together. So okay, so this guy at this point is pretty much all set. We are not going to connect the LCD screen yet. That's going to be done during the final assembly. But for now, what we're going to do is we're going to move on to soldering the button PCBs. So, okay, I think definitely in terms of some assemblies, those were definitely the main kind of, or the most difficult parts of the build. Certainly was soldering that PCB together. Okay, so a quick explanation of how the button mechanism works. Again, basically with eyes towards cost in mind, being able to basically try to keep the cost as low as possible so that we can get as close to the price of an official Stream Deck as possible. I wanted to come up with a button mechanism design that would be basically easy to assemble and didn't require any kind of exotic parts. So for example, in the Elgato Stream Deck, what they seem to use is basically a rubber gasket, which is probably laser cut, and that sits on top of a resistive pad. So what happens is every time you push a button, that rubber compresses. You force that, or you sense that pressure with the underlying flexible PCB underneath, and that's what registers a button press. That's really cool, again, for kind of keeping a low profile and giving you a nice little rubbery feel when you push the buttons. But certainly for anybody looking to build a Stream Deck at home, they're probably not going to have access to a laser cutter or anything like that. So I instead opted to make the entire Stream Deck using a set of push buttons. So the way this works is that underneath this PCB here, we have an LCD screen, and then soldered into around kind of each of these holes on this keyboard PCB, so these little square windows here are basically where you would see the icon pop through of the graphic that's displayed underneath the screen. We have two things. We have a bunch of push buttons, and the push buttons around the buttonhole are wired in parallel, so that no matter which of those buttons you push, you will register a button input. And then on top of that, we basically have this 3D printed frame with an acrylic insert, which you can buy online from several hobby vendors for really, really cheap, these acrylic squares. And you basically press these in, and then these sit on top of the button PCB, and then anytime you push the button, it then registers as a button press. So a nice way to basically try to keep everything again as easy as possible and as relatively inexpensive as possible, while still being able to kind of maintain the core functionality of the DIY Stream Deck, which is of course being able to have an LCD screen underneath and being able to see the buttons. So I also see Johnny Bergdahl right here commented, you can find Dustin's design on GitHub under username Dustin Watts. It's an ESP32 touchdown microcontroller for the hardware and Free Touch Deck for the software. So Free Touch Deck must be a software package that exists for his variant of the Stream Deck. Very cool. I will definitely be checking that out. And maybe it'd be cool too if in the future it'd be possible to kind of maybe merge these two designs and then maybe have like a unified infrastructure for all these open source Stream Decks. That would be super cool. So thank you so much for sharing that. We just have actually DSK001 also joining the chat saying, hi, Alex. I had mentioned him previously. If you check him out on Twitter, you can see his remix of the Stream Deck case that he shared with the community also, which is really cool. So that's another version of the Stream Deck. Definitely check out that design, and thank you so much for stopping by. Okay, perfect. We are now ready to solder the buttons. Here we go. So again, what I did in preparation for this stream is I basically took all of these push buttons here, like this, these little guys, and then just inserted them into the corresponding hole of the circuit board right here. And then the first step that we're going to do is we're going to go and solder them all to the board. The good news is that because these aren't wire, the soldering here should be relatively quick because they're rigid pins. Again, one thing I will note is that while soldering here, this guy is a solder fume extractor, which is basically just a fan and a filter. If you guys will be doing a lot of soldering, I would definitely recommend that you have one of these handy, just because solder fumes are not a good thing to breathe. We want to make sure that everyone stays healthy and can continue to do these electronics projects long into the future. And as we see here, I mean, soldering, you do kick up quite a bit of fumes. So very happy to have this solder fan here. Definitely worth getting. I think I paid maybe $15 for this guy on Amazon, and it is well worth the investment. Alrighty. making good progress here with the soldering. Hybrid is asking me, why are you soldering? So I am soldering these buttons because they need to have electrical connections with the PCB underneath. So just to make sure that the electrical connection for these buttons is good between each of these buttons and the PCB, I'm just adding a bit of solder through all the through-hole components to make sure that the electrical connection is good. All right. Perfect. Alrighty. Almost there. We're almost halfway there, I should say. Cool. So yeah, while we're soldering here, just in the chat, does anybody have any cool projects that they're excited about or they're working on? I'd love to hear it and love to share. It's always exciting to see the kind of projects that other people are working on. Certainly, I think for me, and I'm sure for a lot of other makers there, YouTube is always a great resource, and it's cool that there's really this DIY hobby electronics community that is, you know, kind of existing on not only YouTube but also on Twitter, where people share their projects. Seeing other people's projects is a great way for me personally to learn. And with each kind of project that I build and with each project that I watch from other people who make it, I always tend to learn a little bit more in the process. And yeah, it's just a great resource to have for people looking to get into electronics. So a bit of backstory, I guess my background is actually in mechanical engineering. So all of the electronics knowledge that I picked up was pretty informal. So I took an intro to circuits class once as an undergrad, and then took a systems engineering class later that, you know, kind of introduced me a little bit to the basics of Arduino. But since then, kind of everything from PCB design to, you know, learning kind of how to connect various different types of components together with various different types of communication protocols. All of that info was basically picked up through free online resources. So again, I think it's both YouTube and, you know, Twitter and GitHub is a great way to learn. I think, you know, electronics, I think to a lot of people can seem scary at first, but certainly it doesn't have to be, and actually it can be quite a lot of fun, especially now. I mean, when Dustin Watts had said that his Stream Deck is built around the ESP32, that microcontroller can actually access the internet. So that's like being able to access the internet through a microcontroller is like a whole different level of possibilities of things you can do. Of course, you know, there's also Raspberry Pi. There's also Raspberry Pi, of course, which is great at combining both open source electronics and Linux, which is really cool. So yeah, we live in a cool time where electronics, both knowledge and components, are easily accessible, and really all of the things are there to make it possible for anybody who wants to learn these things to learn them at their own pace, doing a project that they think can be fun. So that's really cool. All right, we are just soldering the last button here, and at that point we should be good to go with this. Okay, perfect. All of the buttons are now soldered. Again, I mean, this just looks super cool in the black and gold. That's very, very exciting. Okay, We have a quick question that says, can you use KiCad? You use KiCad for designing this PCB. So for this PCB, I actually used Eagle. Eagle is a PCB design software made by Autodesk. And like KiCad, it is free. The nice thing for me about using Eagle for this project is that it integrates very well with Fusion 360, which is the CAD program, also made by Autodesk, that I used to design the 3D printed components for this project. And I guess personally, I found that very nice because you can basically have an electrical design, and then you can import that directly into Fusion. And then with Fusion, you can then design your case around it. And basically, you can keep kicking the design between Fusion and Eagle back and forth. And every time you connect your Eagle design to a Fusion file, what happens is you basically get a full 3D model of your circuit board with all of the components. So that makes designing CAD around a circuit board extremely easy. Let's see. So let's see. One other piece of software that I'm beginning to use now is Altium. And Altium is a PCB design software very similar to Eagle. But unlike the free version of Eagle, Altium has a few more capabilities for doing like higher layered number of boards and larger boards. And that's kind of handy for me for some of my future projects that are coming up soon. Because of that, I'm kind of exploring different types of softwares. Certainly, though, whatever software I do end up using for a project, you can be sure that I'll try to make a tutorial about that software, so that regardless of what software you decide to use, you can go ahead and do that. One quick note, actually, while we're speaking about Altium. I have to give a quick shout out again to PCBWay. So as you may have noticed, I'm wearing a pin here, which is basically a pin, a push button pin with LEDs on the back. And this is really cool because if you try to usually make enamel pins, they can be somewhat pricey. But PCBs are a cool way to make pins that you can wear while also having a cool graphic on the back. So I'm actually making these available for people who want to support projects like this on Patreon. It's available at the newest patron tier that we have made. And these boards were actually designed in Altium, so a different PCB design software. But I guess for supporting me on Patreon at that level, what you will get is you will get a copy of these pins, and you will also get a set of components that you need in order to make sure that the pins light up, along with any of the LCDs that you need. So if that's something you're interested in, definitely please check out the Patreon page. And yeah, if you feel like that's something you can do and you want to support future episodes like this via Patreon, that's certainly appreciated. Definitely, watching and liking and subscribing and supporting me through those methods are a great way to ensure that the videos that I make on my channel and all the design files will always be free for everyone to learn, and just help me finance kind of my next round of projects. So. Thank you for everyone who's tuning in today, for watching and subscribing, as well as everyone who's currently supporting me through Patreon and through other crowdsourcing means. Okay, so now what we're doing is we are connecting the ribbon cable that we had previously soldered to the button PCB onto the onto the key PCB here. see. I know what I'm doing is I am almost done soldering. Like I said, certainly we definitely started off with the more difficult PCB of the two in terms of soldering and getting everything going. So I think from here on out, fingers crossed, it should be relatively smooth sailing. That those wires are twisted enough to fit into the hole. One trick, certainly, if you are assembling this Stream Deck at home, is you could probably pre-tin each of the wire leads, and then that way they will fit through the holes a little bit easier when you're soldering. I guess we're almost done with these, so probably not worth it to do it for this one, but something that we can do. Okay. See, there is some activity right now happening in the chat, which is really cool. It seems that there's a discussion going on about different Stream Deck designs that people are discussing. So I hope definitely that I see a lot of remixes in the future. So Tobias is commenting. He likes the top cover of this Stream Deck more than the old one. Yeah. So. Definitely for the first round of Stream Deck designs, I wanted to go with kind of a more organic shape, which was really cool. Basically, I just wanted to kind of play around with the Voronoi sketch generator within Fusion 360. One of the nice things about that particular Stream Deck was because it basically had a lot of holes in the case, it made printing everything super duper fast, which was neat. But certainly for kind of a quote-unquote Cyberpunk-themed Stream Deck. You want probably something that's a bit more angular, a little bit more tech-looking. So I decided to go with this kind of remix design for this newest deck. Just want to make sure that all of my leads are connected correctly. Looks that way. Fantastic. All right, 4 more wires to go, and then we can solder in the encoders. And then we can get ready to program the Arduinos. Okay. Oh, that's a really cool idea. Dustin is looking to use the Stream Deck with Home Assistant to control some functionality within some of his smart devices in his house. That's a really neat idea. Like kind of a universal remote for all your gadgets. That's super neat. I know that the official Stream Deck also has some integrations like that. For example, I think by using if this then that online, you can basically, through your computer, basically assign different macros to the Stream Deck, and you can do things like order pizza, which is awesome. Imagine sitting here and then just being able to order pizza at the push of a button. It shows up. That's fun. It's living the dream on a lazy Saturday. All right. One more lead to go. Tobias is asking, can I use the rotary encoders to cut video? Yes. Actually, so we're going to take a look at that in a minute when we program the Arduinos. But right now, the way the Arduino code is set up is that the encoders, moving them left or right, basically emulate pushing your keyboard button left or right. And then basically by turning those knobs at left and right, it's basically like pushing left or right really quickly on your keyboard. So you can kind of scroll through the videos and then kind of push down like this by clicking to actually do things like cut videos and things like that. So that's really cool. All right, so the last thing to solder, well, actually, I guess before I do that, what I'm going to do is I'm going to trim some of these leads just to make sure that nothing is shorting out. Snip, 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 snip. Snip, snip. Okay. Cool. All right, now we're going to solder these rotary encoders on here. So let's do that. Perfect. Here is one. And where is the other? Aha, it's hiding back here. It's going in. Perfect. Just like that. Oh, move it over here a little bit more so you can see it a little bit better as we're soldering. Flip that around. All right, cool. And the way these connect to the circuit board is actually really interesting. And I guess it makes sense because these connectors see a lot of force, these rotary encoders. What happens is you basically, quote unquote, almost, I don't want to say weld because it's obviously not welding, but you basically dump a lot of solder into just some of the mounting holes just to make sure that it has a good grip. Then of course the communication pins are small. That's neat to basically use solder as a mechanical interface. I guess it's pretty common, but as a mechie, I always like to see where the electrical world and the mechanical world kind of collide, and where you can use the concept from one, like soldering electrical connections, you know, into the other of making like a good strong connection. That's cool. Alrighty, so at this point, barring any fixes that we will have to do because of a broken wire or anything like that, I actually think that the soldering for this job or for this board is done. So I am going to turn off this fan. Okay, and at this point, I think we're ready to proceed with programming the Arduinos. So to do that, I will switch back to desktop view, and we are going to go back to github.com/supermakesomething. And again, the links to all of these project files and all the code will be down in the video description below. And then once we're at GitHub, we are going to go to this button here, click download, click the code button, and then we're going to click on download zip. And we're going to save this. Let's see where it's saving. Okay. I'm going to save everything while I move this to the desktop. Oop. Yeah. Okay. And now we should see the file on the desktop right there. Oh, let's see that the chat box is currently in the way. All right, so what we're going to do is we're going to extract all of this code, again, just to a folder on the desktop. And inside here, we have a folder called DIY Stream Deck main. Right here. And inside, we have basically a copy of the directory structure that we saw on GitHub. So the first thing I'm going to do is I'm going to go into the Arduino libraries folder, and we see two folders here called lcdwiki_GUI and lcdwiki_kbv. And we're going to take both of these files and we're going to move them into Documents, Arduino, and Libraries. And these will then be Arduino libraries that are referenced when the code is compiling, and that code will then be uploaded to each of the Arduinos. So after that, we are going to go back to that folder. We're going to take Arduino code, and here we have two different libraries again. One is called Arduino TFT_icons. So this code is going to be uploaded to the Arduino Nano, which is responsible for reading all of the image files and displaying them on the LCD screen. And then we have another one here called Stream Deck Keyboard. That is going to be the code that's going to go onto the Arduino Pro Micro, and that is basically where you assign which buttons you want to be pressed as a quote USB keyboard when you push certain buttons on your Stream Deck. So, all right, so first order of business is what I'm going to do is let's begin by programming the Arduino Pro Micro. And I'm going to make a little bit of room here on my desk. And just so you can see what's going on, I'm going to switch to the secondary camera real fast. And first thing we're going to do is we're going to take this micro USB cable here, and we're going to plug it into the Arduino Pro Micro right here. Things are lighting up. The magic smoke still seems to be inside, so that's a good sign. One thing I should also say is that obviously while you do need, unfortunately, two different USB connectors to connect to program the Arduinos, the power rail is actually connected in parallel to both Arduinos, so you will only need one USB cable connected to your PC in order to power the entire Stream Deck and to drive all the buttons. So that's a nice feature because obviously you want to avoid having to connect two USB connectors to your computer if you can help it, just because obviously USB connectors can be at somewhat of a premium in a computer. So, okay, so now we have opened up the Arduino IDE. The first thing we're going to do is we're going to go to File, Open, and there we will navigate to the desktop where we had downloaded our code in the Stream Deck main. We're going to go into Arduino code, we're going to go to Stream Deck Keyboard, and we're going to open up the .ino or .eno file, which we see here. And let's just do a quick walkthrough of the code. So one thing that I did here is I did not use keyboard interrupts, which is usually what you want to do with an encoder. Again, that's just due to the button layout. But an interrupt basically, as its name suggests, basically interrupts any code that's running on the microcontroller currently when you move the encoder left or right. And that's just done because an encoder has to be read extremely fast when you click it left or right, because it counts how many times you, like the little reader inside, moved left or moved right. So I want to do that entirely through software, so I disabled interrupts. Then what I did here is I define my two encoders. So my up-down encoder for my up-down arrow. In that case, that would be, for example, for adjusting volume, as well as my left-right encoder for being able to scrub through video going left and right. And then here I define two arrays. So one I call button array 1 and one I call button array 2. And like I said, so one of the big advantages of having a Stream Deck is that you don't have to remember what keyboard buttons basically are assigned to what button, but obviously the number of physical buttons that you have on a Stream Deck are limited. So in this case, we only have 6 physical buttons. So what I did is I added one of the Arduino lines and connected them together so that they talk to each other. And what that allows it to do is basically every time I press a button that I've dedicated to the Stream Deck to quote-unquote change the page, what it then does is it basically loads the other set of keyboard shortcuts that correspond to a set of buttons on a second page, reloads graphics, and then what you basically have is you have 2 distinct pages of buttons on the Stream Deck that you can cycle back and forth in between to basically up the functionality from having only 6 buttons to now having 12. And because everything is stored on an SD card in terms of icons, really the only limit that you have is Arduino memory, which is just kind of defining more button arrays, and then any storage limit that you have on your SD card for the icons that you're trying to install. But you know, up until the limit of the number of characters that you can store in this character array, you can have quote unquote an unlimited number of buttons, basically, where you can have 3 pages of buttons, 4 pages of buttons, and you can basically cycle between them, and then all of those buttons do the same thing, or do different things. So that's kind of a handy way to basically expand the functionality of your macro keyboard, and is again one of the really nice things about a Stream Deck, because you can basically dynamically change what macros are active on your keyboard at a certain time simply by changing the kind of page of buttons that you're currently on. So the rest of the code is basically just initializing everything. And then in order, again, to minimize the number of components, I use the input pull-up resistors that are on the Arduino already integrated, so we don't have to solder those ourselves. And then underneath here, we basically just have a bunch of code that registers a button press and then sends the corresponding keyboard commands. So here, for example, in this if statement, we basically say if the current voltage on the buttons assigned to pin 3 is low, and if I'm currently if my page flag, so if I'm currently on page 1, then what I want to do is I want to set that page flag to 2, and then I want to write out a high voltage that is then read by the other Arduino, and is then basically a cue to that Arduino Nano to change the buttons that are being displayed and to change the macros. And then similarly here, we have a bunch of if statements where if my page flag is 1 or 2, so again, if I'm looking at page 1 or page 2 of the buttons, I want to then send the corresponding character as a USB keyboard button press out from the Arduino. So send that keystroke corresponding to the characters defined here in this button array. So again, it's not really limited to sending individual characters. For me, basically, I just did that to kind of keep the example code simple so that it's easy to understand. But certainly, in addition to just sending one button press, you can send a whole set of different commands and really chain a lot of different button presses together so that the macros that you potentially program into this device can get pretty elaborate and lengthy, and you can do some cool stuff with it. So, okay. Now that everything is attached, what we're going to do is we're going to go to Tools, Board, and we're going to select Arduino Leonardo. So this Pro Micro uses the same software, I guess, bootloader and configuration as an Arduino Leonardo, which is basically a bigger version of this microcontroller that is shaped like an Uno. Then what we're going to do is we're going to go to port, and we're going to go to COM3, so it sees that the Arduino is connected, so that's great. And then what we're going to do is we're going to press the upload button. At that point, what it's going to do, it's going to compile the sketch. I see that I have an error here, and it looks like I am missing the encoder.h library. Now, why would that be? Let me go and grab that real quick. It should have typically come pre-installed. Yeah, it should be installed, which is strange because I'm running a later version of the Arduino, but okay, that's fine. Let's see here. Okay, let's go grab that encoder library as well. So similar to what we did to downloading our own Arduino code, we are going to grab this, click code, download zip, save file, it's downloaded twice for fun. I'm going to cut that out, move it to the desktop here, and then unzip it and place it into our Arduino libraries. Okay. All right, what we're going to do is we're going to restart the Arduino IDE just for good measure to make sure that it sees it. Tobias is saying, yeah, he ran into the same problem when he transferred the software. Yeah, so actually, all of this original coding for this project was done on my desktop right now. That's actually being used to stream. So this is a brand new setup on our laptop. So I'm glad. I guess I had that previously installed and didn't realize. So, but that's okay. So keyboard.eno. That's open. Because of limited desk space, I'm also using my touchpad instead of a mouse, so that's making navigation a little bit challenging. Okay, it looks like all the options are configured. We're going to hit upload again. Will it find it this time? Yes, it does. All right, excellent. Cool, the Arduino code is now uploading. And actually, what I will show you here is, because it's always fun when you click upload, the Arduino blinks. You can see there, so it is accurately programming and perfect. It looks like we are done. Okay, so the macro keyboard is currently, the keyboard portion is currently programmed. We can try it out. Right now it should act like a USB keyboard. Oh boy, excellent, and look at this. What we see is that when we push the button here, if I'm just gonna switch back to desktop mode really quick, you can see that buttons are indeed being pressed when I push the keyboard button. So very exciting. The button portion of everything seems to work. The scrolling also seems to work. So when I press the encoder, or when I turn the encoder left or right, we see that the scrolling through the text moves left and right, just like that. So that's fantastic and excellent. All right, so we are halfway there. Very exciting. All right, so now we are going to really quickly switch back to here. I'm going to now disconnect the micro USB cable, and I'm going to take my other USB cable, which is a USB mini, and I'm going to use that to program the Arduino Nano. And while soldering, let me see where I placed that cable. I just had it. Let's see, where did that USB cable go? Aha, it is on my desk, safe and sound. Excellent. All right, so here is the other USB cable, which is the micro. It's a little bit of a bigger connector. What I'm gonna do is I'm going to carefully move this around and plug this in just like this to here. Again, trying to make sure that nothing is touching. And then I'm going to plug this guy in. Okay, again, both power rails are connected together. So when plugging in one USB cable into either Arduino, it powers both Arduinos up together. Again, though, a thing to keep in mind that if you want to use the USB keyboard functionality, you will need to have the USB cable connected to the Arduino Pro Micro, which acts as a keyboard. So in essence, really the only thing that's interfacing with the Stream Deck is that Arduino, or I'm sorry, the only component of the Stream Deck that is interfacing with the computer is the Arduino microcontroller that is acting like a keyboard. So, okay, so with that done, we can now go to File, Open, and we're going to open the Arduino TFT icons.eno folder. This library this code here is a bit more involved. Really, there's not much for you to change here in case you're building your own Stream Deck. A lot of this code has to do with exactly how kind of things get rewritten in terms of graphics to the LCD screen. But that's not something I guess that you should really need to play with. So the nice thing is, like, you just really have to just upload this code and you should be good to go because it's already pre-configured to use this 3.5-inch LCD screen that you can purchase from multiple sources online. So, okay, to program this, we are going to go to Arduino. We are going to go to Arduino Nano. We're going to go to Tools and Processor. We're going to go to Atmega 328P Old Bootloader. And we're going to go to COM port 6. We're going to hit Upload. This library is a bit bigger, so it takes a little bit longer to compile. But it is compiling, and it is currently uploading. So the lights are flashing. If you can see that, I'll just upload it again so that you guys can see. And this is actually quite a big sketch just because there's so much code involved with kind of interfacing with the LCD screen. It uses 67% of the memory of the microcontroller. So, okay, perfect. Okay, it is uploading and it is done. Excellent. All right. So at this point, really, the next thing that we should try to do is just to see if all the electrical connections are correct and if the screen can display graphics. One thing I did prior to this live stream is I basically went into this icon folder here, and I uploaded, or I already copied all of these icons that you see in this directory to an SD card. If you're interested in using those icons, you can just use those as is and just copy those to an SD card yourself. Alternatively, you can also make your own icons, and for that I have included a Photoshop template in case Photoshop is something that you have access to. And the only really important thing to remember is that when you are saving these BMP files, they need to have a certain resolution as defined in the template, and you need to save them as 24-bit BMP files. Which is a format that's required based on the code that's currently on this microcontroller to read button presses and things like that. So, okay, what we're going to do is we are going to now start the assembly, really. But before that, like I said, we just want to test the screen. So what I'm going to do is I'm going to switch back to this camera view here, and we want to just plug in the screen to make sure that it's or that all the pins are aligned correctly. So as you can see, just like this, all of these slot into one of the female headers. Again, since there's not a great way to kind of separate these connections, can be a little tricky just to make sure that you're plugging things in correctly, so just something to be aware of. Okay, going to insert the SD card into the SD card reader. I'm going to switch back over to the other USB cable. Back I go. Where are you, USB cable? Ah, it's down here. Okay. And at this point, we should hopefully see something light up. Oh yeah, we got it. It is plugged in and the icons are rendering. So that means the Arduino Nano works, which is really cool. It means that we just tested that the keyboard works, which is also really cool. So now we are literally in the home stretch, and it just means that the final step is to assemble everything into the 3D printed enclosure. So one thing you will note here is that you'll notice that these icons are spaced in kind of an interesting way on the LCD screen. This is basically to make sure that you can see each of the icons underneath each of the kind of buttonholes for the PCB. And actually, I think this is kind of also the way that it's done in other Stream Decks. Instead of having individual buttons, you have one giant LCD screen, again, just to kind of bring manufacturing costs down. But overall, Dustin Watt says success. Yes, absolutely. Very excited. So at this point, let's continue with the build, and let's get on to assembling everything. So I'm going to unplug this guy real quick. And then I'll show this video here. So obviously, you know, 3D printing can take a bit of time. So what I did is for this build is I 3D printed all of my files ahead of time. I have not yet released these files on GitHub, but we'll do so after the stream, just in case, you know, in case we find any kind of last minute things where things don't fit during the assembly, that we'd be able to fix those before releasing those files to the public. But in case you're interested in seeing some of those prints being made kind of as I took video, I actually have an hour 3D printing video of the 3D printing process uploaded as a separate video to my YouTube channel, using some lo-fi background music, since I kind of like watching 3D printers, you know, slowly do their thing, and I kind of find it relaxing to watch things build. And the music playing in the background is from Stream Beats. So Stream Beats is a royalty-free set of music playlists by Harris Heller, who runs the Alpha Gaming YouTube channel. And he has basically released this royalty-free music for anybody to use, so that, you know, you won't get a DMCA copyright strike or get demonetized. So in case you're interested in either listening to some lo-fi music, or you're interested in seeing this 3D print kind of in action being built for the parts that we made here today, definitely check out that 1 hour lo-fi Stream Beat playlist mix. And a big thank you to Harris Heller for making that music available online. So, all right, what we will do here now is the following. I think what we'll do is we will start by screwing. So first thing we're going to do is we're going to remove the LCD, because that actually, the way it's assembled with the screws, and the way that interface PCB mounts to the case needs to be installed first. So what I will do here is I will very carefully insert this PCB inside, just like this. And then I will use M3 screws to attach everything together. Oh, I try to use, again, for this design to kind of bring costs down, try to use as many of the same screw as possible and nothing exotic. So all of the screws in here, except for 2 of them used to attach the SD card reader, are M3 screws. And I use 2 different screw lengths, but all of these screws should be possible to use with 10 millimeter long M3 screws. So, you know, again, just in case you're building the Stream Deck for yourself, you don't have to go and buy like 6 different types of screws. And hopefully, you know, things will, again, just be a little bit easier to assemble and to work with. So, in terms of actually inserting the screws into the plastic, so, you know, typically if you're threading something into a fastener into a material, you have to pre-thread the holes. I have found that with 3D printing, actually, is if you just oversize the holes a little bit, you can actually use the screw itself to kind of cut threads into the plastic as you're tightening everything down. So again, that's what I did here. Again, with the idea that if you're going to build these, you don't want to have to go out and buy a set of taps to pre-tap the plastic and then to insert the screw. So again, the motivation was just to make things as easily assemblable with the tools that, you know, you may already have on hand, or at least something that requires you to buy a minimum amount of new tools. Okay. So next, what we want to do is we want to carefully move this button PCB out of the way. And then take the SD card PCB and attach it into the enclosure. Unfortunately, these aren't compatible with M3 screws, so it does, this part of the design does use two, I think they're M1.5 screws or M2 screws. These are somewhat optional. Honestly, you could probably just as easily attach these to the plastic with some hot glue. But I guess for this, just to keep everything clean and not have to worry about heating up some hot glue, I decided to use screws. But certainly these are kind of a bit more on the optional end. Again, because you only really need two of these. So unless you have them handy, no sense in buying a 50 pack of M2 screws if you don't need to. So again, similar thing, the holes are a little bit oversized, so that we should be able to just thread these in there by applying a little bit of force and cutting the threads with the fastener. There we go. Cool. And same thing with this one. Make sure everything goes down correctly. All right, cool. We are in business. So now what we will do is we will gently tuck this cable off to the side so it runs underneath the screen. We're going to move the button PCB sideways, and we're going to reattach the screen. Okay. In terms of getting everything mounted, again, this is always a little bit tricky. You want to make sure you don't bend any of the leads, anything like that. Kind of have to plug these in blind, you know, which is not ideal, I guess, but I guess by having the Voronoi case, you at least got a little bit of visual feedback, but I think we're okay. Let's just double check that everything is still, or that the screen was connected correctly. So we're going to take the USB pin of the keyboard here and plug it in. The screen is not lining up right now, so I think I might have missed the hole. So let me take that out again real quick. Again, along with soldering the, oh yeah, we have a bent pin. Along with soldering the ribbon cable, definitely one of the more fiddly parts of the build for sure. I keep missing that pin. It's that one pin. I'm just going to move these down a little bit at a time until we have the right connection. Definitely something that I think I will keep in mind for the remix here is that I will definitely be adding a window, I think, on the side here, just to make sure that everything connects correctly so it's easier to see. Got it. Hooray! Okay, fantastic. Yeah, definitely. I think that's one of the things I'll do is at least maybe add an indicator to kind of help with the alignment a little bit, just so that it's a little bit easier to plug that screen in. Otherwise, it's a lot of disconnecting and reconnecting and going back and forth. So, okay, so with that in there now, what we're going to do is we're going to take this final piece, which is meant to basically act like a little protector for the LCD screen, and put it in here like this. Again, this has some windows overlaid through it, where you'll easily be able to plug everything in. And then on top of that, we are going to mount the button PCB. Just to stick with the cyberpunk aesthetic, I'll leave the wires poking out here a little bit, but I mean, certainly not something you need to do. And there's certainly enough room in the case to make sure that everything plugs in correctly. So again, same story, M3 screws, screw those in there, and then everything will get connected. Awesome. Again, a big thank you for everyone who's tuning in today and who came back after OBS crashed. What you'll see me doing during the live stream here is just nervously peeking over to the right-hand side where I have my second computer monitor, just to monitor that Streamlabs has not crashed again. Thankfully, that only seems to have been a one-time unfortunate occurrence. Knock on wood, everything has gone smoothly besides that. So if that's the one bit of technical difficulty that we encounter during the stream, I'll take it. One other note is, so what I'll be doing is I'll be releasing this video as a standalone episode, as some people have mentioned in the comments, after we finish this build here today. Usually what I do is I upload it immediately after the stream completes. However, since we did have that technical hiccup where we had to restart a stream and it restarted with a new stream address, what I will do is I'll edit those two video parts together, and then what I'll do is I'll upload that as a kind of combined edited video as under a new link. So unfortunately what that means is probably for this stream here, the chat history will get lost, but that's why I did kind of activate that little chat window in the left-hand side of the screen. So even though we won't be able to see a live chat replay through YouTube, at least some of the questions that you guys asked during the stream will be shown in the video, so that people can follow along when you guys asked your questions. So, okay, so that's in. Let's see. Don't really need this final screw here, but maybe we'll just put it in for completeness. Cool. Get there. All right, I can also actually move the solder fan out of the way since we are done soldering. And then really quick, just to give it some kind of techie cyberpunk colors, I will add a bit of glue here. And I've made basically this this insert where we can decorate a little bit with an outer border in pink and blue. I will also say that part of this PLA comes from a company called Ancun. They make a lot of these PLA pluses, which have these really cool kind of silver pearlescent shine. They provided all of the PLA for this video, and also offered some discount codes that you can use in case you want to order the same colors that I used here. For those discount codes, please take a look at the video description. By using those Amazon affiliate links and adding those coupon codes during checkout, you will get 15% off the price. So definitely something to think about if that's what you would like to do. Okay. Okay. Same here. All right, that glue is probably going to take a little bit longer to dry than it would until the completion of the stream. But, you know, just a heads up, I mean, just a reminder to hot glue those pieces in if that's how you would like to decorate your Stream Deck. Okay, now it's time for the buttons. Again, just a quick refresh. For the button mechanism, it basically looks like this. So we have the button PCB sitting on top of the LCD screen, and then we have these acrylic inserts with these 3D printed button caps with little flanges on the side that sit on top of the 4 corresponding push buttons. And what you simply do to attach these is you these are a light press fit. So you have these 20 millimeter by 20 millimeter acrylic squares. They simply push into the recess here and sit on top of a little lip. And then what you can do is you can basically just place these on top like so. And we're going to do that 5 more times for a total of 6 buttons. Just like so. Now, one note too is that these, in order to kind of like interconnect mechanically, they will fit a couple different ways, sort of, kind of like if you jam a puzzle piece into a puzzle kind of at the wrong location. But there is one correct orientation for these, and you'll feel these, you'll feel it like that it's the correct orientation when you put the button covers on. What you could do is, if you have a multi-material printer, is maybe just color code one or mark it in some way, even with a Sharpie after you print it, for easier assembly, so you know what orientation these go into. But again, that's just an optional step that would make the build a little bit easier, but maybe something that I will do in the future for those that have access to a multi-material machine. Okay. Here we go. All right, all those 4 buttons are on, but I think one of these is not at the right orientation. Yeah, if they're at the right orientation, they'll have a little bit of wiggle. So maybe it's this bottom row. Nope. There we go. Perfect. All right. And one more. Okay, perfect. So these guys are on. This button frame here basically nests around these buttons to keep everything in place. So you don't need any glue or anything to attach them, which is kind of nice. So, and again, you should feel that if they're incorrectly, there should be a little bit of wiggle. For all these buttons. So, alrighty, next up is we are going to take the screws here. I think in retrospect I could have made these holes a little bit bigger, because these should actually be clearance holes. That's okay, I will update that CAD before releasing these files. But for now, we'll go with it. Yeah, these holes are a little bit too tight. So that's okay. Okay, almost done connecting or inserting these screws here. And last one. Yeah, I kind of like these new PLA Plus filaments that companies have recently started selling. So not only do they have a really cool kind of pearlescent color, but apparently they also have mechanical properties that are more similar to ABS instead of PLA. So you know, they have a couple different uses, or kind of more expanded uses, I should say, compared to the standard PLA, without being more difficult to print. So I know with ABS you usually have to have an enclosure, and you have to keep your temperature and all that really well controlled. But instead with PLA Plus, you basically print it the same way you print normal PLA, but you get some of the kind of additional mechanical benefits in case you're doing something that requires that additional strength, for example. Again, having made these holes a little bit too small here, and this top cover is coming back to bite me a little bit, so these should be clearance holes again and not threaded. Before releasing the final CAD, I will be updating these files to make sure that that the holes in the top cover are indeed clearance holes. There. Still waiting on that glue to dry a little bit. Certainly yeah, that's something I'll take care of after the stream, just to make sure that that crazy glue is super dry. All right. But we are okay. Overall, we are looking pretty good here. These encoders, the knobs here, just press onto the encoder tops. So they have a little bit of geometry in there to make sure that they mate with the appropriate connector here. Come on, you. Bit of a tighter fit than I liked. I guess this is strange because bit of a tighter fit than the ones on the old Stream Deck. I wonder if something happened during the re-leveling. Yeah, super tight. Okay, just to not force it, not to break anything, what I'm going to do is I'm going to take the old knobs from the other Stream Deck that I built during the project video off, and just insert those. Again, the fit is a little bit tighter than I was expecting, so that's another thing that I will be sure to update in the CAD before releasing these files. And then, so I guess while we're getting these on, aha, perfect. So Philippe asked, why not use the integrated card reader integrated in the, why do you not use the integrated SD reader on the LCD screen? So this is a good point. As Philippe points out, there is an SD card reader on the LCD screen. But what I found that during building this project and then doing some Googling online, it seems that the integrated SD card reader is very power hungry, or more specifically, it requires a lot of current. So what happens is when everything is powered from a single USB connection, which includes both the screen, the SD card reader, and the two Arduinos, basically it seems that the USB port isn't able to provide enough power. And then what happens, therefore, is you get a SD card initialization error, and you don't end up reading the image files. So the workaround that I found for this was to basically use this external SD card reader, which has its own onboard voltage regulator, but seems to require less power. Certainly, that's one of the things that I'm hoping that will be addressed in future revisions of the Stream Deck. So basically, by needing to have two Arduinos, you kind of also make the sacrifice of needing to have this external SD card reader because of the current limits. So yeah, as you point out in the chat right now, the USB connector has a 500 milliamp max power, or max current that it's able to supply. So in the future, I think definitely by redesigning the Stream Deck here to use a different microcontroller, like for example the STM32 Blue Pill board, which has both enough I/O to run the LCD screen, which was really the driving decision behind using two Arduinos. By basically swapping those two Arduinos out with that microcontroller, that would then also allow you to use the integrated SD card reader on the screen. And of course, the practical benefits of that would be multiple. So one, the Stream Deck could definitely be a lot thinner in terms of the vertical direction, just because you wouldn't have to kind of worry about having additional vertical spacing to be able to route all the wires through for the SD card reader. But certainly also the overall design would be simpler, and it would be one less microcontroller that you would have to solder. Now, the drawback to using that microcontroller, the STM32 Blue Pill board in particular, and I choose that one because that microcontroller also has a lot of LCD screens that are compatible with it in terms of kind of the software libraries that people have written. But the issue with that stock microcontroller out of the box is that if you the way that it comes configured is you need a separate external programmer to program that board, which makes programming the board a little bit more difficult. So again, for purposes of this project, I wanted to stick with Arduino just because everything was kind of easy to program and easy to use. But certainly, you know, if people would kind of be comfortable enough to instead use an external programmer to reprogram the microcontroller, that's certainly another option, and that would definitely have a lot of benefits. So definitely something I would like to keep in mind for future revisions, and that would also allow you to use the integrated SD card reader. So, okay, so at this point, to be quite honest, I think we're pretty much done. So what I'm going to do is let's just do a final test. What I had originally planned to do for this stream was to basically now configure the Stream Deck in Streamlabs and show that it can be used basically to configure like the SD card reader and stuff. But I think what I'll do for purposes of this video, just because there were some maybe streaming issues before with Streamlabs, instead what I'll do is I'll just go back into Notepad. Again, just show that the button presses work, which is very, very cool. And as we can see here, it is sending keyboard commands appropriately. Scrolling left and right also works. And then clicking the buttons on each of these also makes different things happen. So perfect. There's like an enter button, things like that. But yeah, we can see the encoders work, both with the scrolling. Pushing the button makes different buttons work. And overall, I think this build was a success. So I'm very excited that this worked. Again, kind of a little bit of streaming snafu aside. Oh, I just bumped the USB cable, so the unit is resetting. But overall, this was a successful build. So As I had said, so all of the files needed to build the Stream Deck for yourself will be available on GitHub. Currently, all the code and all of the Gerber files that we used are currently online at GitHub and can be ready to use with the old version of the Stream Deck. I will be uploading the CAD files with some of the fixes that we discovered here later on, and then also send out a message to let you guys know that those are live. Specifically, the two things that we're going to address is one, making sure that these guys are clearance holes so it's easier to screw everything together, and then to also make this hole for the encoder mount a little bit bigger so that's a little bit easier to insert. Yeah, so that's kind of the overall project. I mean, in general, again, I just want to thank everybody both for stopping by here today and for bearing with us while we were addressing some of these live stream issues. Thank you also for switching back to this new live stream once we had restarted the Streamlabs OBS live stream. I will be editing both of those streams together into one coherent video, and we'll be releasing that as a standalone episode on this channel as well in the future. What I really hope to have people see is that obviously this is like a really bare bones functional Stream Deck, but I think a lot of different cool things could be done in the future. So for example, as we see, people have written open source Stream Deck software. If the community is interested in basically taking the code that exists currently on GitHub and making it integrate with that software that's available online, so we could maybe see cool things like integrating it into a smart home assistant to control your smart house. That would be really cool. And in general, really, the sky's the limit. So I've made all the files and all the code available for the community to be able to kind of grab things online and remix them as necessary. I hope that in the future we're going to see a lot more Stream Deck variants. But that really pretty much concludes the build today. So everyone, a big thank you for stopping by here today. Again, also thank you for your interactions with the chat and answering questions. Hopefully that both help people watching the stream understand a little bit better about the intricacies of building this version of the Stream Deck, and also hopefully answered some additional questions that people had that may have not been covered in the Stream Deck video. Again, if you don't want to remix the PCBs and you just want to use them as is, you can log on to the community portal at PCBWay, order everything with a single click. Yeah, that's pretty much all I have to say. So again, be sure to please check out the project video associated with this video that's currently live on the channel. If you're interested in seeing the hour-long print of these parts being printed, that's also available as a musical playlist on this channel. But other than that, I hope that you guys have a very happy remainder of your holiday season. I hope that everyone has a safe new year as we close out 2020, which has certainly been an interesting year. I hope that everyone has managed to stay safe and healthy. And in general, just thank you all so much for watching. Again, your support makes this possible. Please remember to like and share both the previous Stream Deck video and this project video once it's uploaded live on YouTube. But other than that, thank you so much for tuning in, and we'll see you next time. Now go super make something. Bye-bye.